Good morning, students. Today in this class we will study about Miller indices. In the earlier class we studied about Bravais lattices. In Bravais lattices there are two-dimensional Bravais lattices and three-dimensional Bravais lattices. In two-dimensional Bravais lattices there are 5 types. In three-dimensional Bravais lattices there are 14 types, that is 7 main system, and among that 7 main system there are 14 main structures. Now we will see about Miller indices. Miller is the name of the scientist who discovered or who evolved this methodology. So what is Miller indices? Before knowing about Miller indices, we should know about lattice points. We already know lattice points. Lattice points are nothing but in a crystal the atoms are regularly arranged, and that regularly arranged pattern is called, that one atom point is called as lattice point. We know these things earlierly. So here we came across about a word called lattice planes. Lattice planes. So what is lattice planes? A crystal lattice may be regarded as made up of an aggregate set of parallel equidistant planes passing through the lattice points, which are known as lattice planes. So in a crystal there are set of parallel equidistant planes. So we know the difference between planes and point. Point is nothing but a single point. Planes is nothing but combination of more points will form a plane. So in a crystal lattice it may be regarded as a made up of an aggregate set of parallel equidistant planes passing through the lattice points, which are known as lattice planes. For a given lattice, the lattice planes can be chosen in different ways. So what is the problem? The problem is that how to designate these planes in a crystal. How to designate these planes in a crystal. Designate means how to name it. What is the plane name? So in order to understand the plane names, Miller is the scientist. He evolved a method to designate a set of parallel planes in a crystal by 3 numbers H, K, L, known as Miller indices. So now you understand, Miller indices is nothing but to designate a set of parallel planes in a crystal by 3 numbers H, K, L. பேர் வைக்கிறது. பிளேன்ஸுக்கு வெவ்வேறு பிளேன்ஸ் இருக்கும். அந்த வெவ்வேறு பிளேன்ஸுக்கு எப்படி பேர் வைக்கிறது அப்படிங்கிறது தான், அதை பற்றி சொல்கிறது தான் இந்த மில்லர் indices. So Miller indices is nothing but a method to designate a set of parallel planes in a crystal by 3 numbers represented by the letter H, K, L, known as Miller indices. Okay, now we should see about the steps in determining the Miller indices of a set of parallel planes. How to determine Miller indices for a set of parallel planes. So there are 4 steps. So what are the 4 steps? First, determine the coordinates of the intercepts made by the plane along the 3 crystallographic axes. Determine the coordinates of the intercepts made by the plane along the 3 crystallographic axes x, y, z. That is, first you should draw the plane along x-axis, y-axis and z-axis. After drawing the planes in the x-axis, y-axis, z-axis, express the intercepts as multiples of unit cell or lattice parameters along the axis. Express the intercepts as multiples of the unit cell or lattice parameters along the axis. So this is the second step. What is the third step? Determine the reciprocal of these numbers. Determine the reciprocals of these numbers. Then reduce these reciprocals to the smallest set of integral numbers and enclose them in brackets. Reduce these reciprocals to the smallest set of integral numbers and enclose them in brackets. So these are the 4 steps in determining the Miller indices of a set of parallel planes. That is, first you draw the plane along the x, y and z axis. Find out the intercepts along the x axis. How many intercepts on y axis? How many intercepts on z axis? Then express these intercepts as the multiples of unit cells or lattice parameters along the axis. Then find out the reciprocal of these numbers, that is reciprocal of the intercepts. After that, reduce these reciprocals to the smallest set of integral numbers. Smallest set of integral numbers means find out LCM. Find out LCM. What is the result comes, then you make that result in brackets. This is called Miller indices of that crystal structure. So Miller indices may be defined as the reciprocal of the intercepts made by the plane on the crystallographic axis when reduced to smallest numbers. So the Miller indices may be defined as the reciprocal of the intercepts made by the plane on the crystallographic axis when reduced to smallest numbers. So these are the steps in determining the Miller indices. In the next slide, we will see an example so that you will easily understand the Miller indices, how to name or how to designate Miller indices for a set of parallel planes. Okay. Now you see how to find out Miller indices for a plane. Let us consider a plane called 623. How this 623 plane came. Now you will see. First step. What is the first step? To find out the intercepts along the A direction, along the B direction, along the C direction. So now you draw a plane in the X, Y, Z axis. Now you divide these planes at equal intervals. Divide these planes at equal intervals. Now you find out along the A direction there is 1A. Here 1A is the unit cell. 1 is the unit cell. 1A. So in the A direction 1 intercept is there. In the B direction how many intercepts? 1B, 2B, 3B. So 3 unit cells are there. So it is 3. Then how many intercepts are there along the C direction? 1C, 2C. Therefore 2C. So first step is to find out the intercept. Okay, we find. Then find out the reciprocal. 1 by 1 is 1. 1 by 3 is 1 by 3. Then 1 by 2. So these are the reciprocal. After reciprocal, find out the LCM. For these 3 numbers, what will be the LCM? 6 is the LCM. Okay, 6 is the LCM. So 1 into 6. 1 by 3 into 6, that is equal to 2. 1 by 2 into 6, that is equal to 3. So find out multiplication by LCM. So first you are finding out the reciprocal. After the reciprocal you find out the LCM value. By that LCM value you multiply the terms. 1 into 6, 1 by 3 into 6, 1 by 2 into 6. So what it comes? 1 into 6 is 6. 1 by 3 into 6 is 2. 1 by 2 into 6 is equal to 3. Therefore, 6 to 3. So, for this plane, the designation of a Miller indices is 6 to 3. So, now in exam, they will give any plane and they will ask how many Miller, what is the Miller indices for that plane. So, in some problems they are asking these type of, in some question papers they are asking these type of problems. So, I think it is very easy. So, first step is to find out, to draw the plane in along the x, y, z axis, find out the intercept, then find out the reciprocal of that intercept, then find out the LCM for that intercepts and multiply that LCM, we will get the Miller indices, and all the Miller indices should be inside the bracket. It should be very must inside the bracket. So, this is the way to find out Miller indices for a plane. Okay. Next, what are the importance of Miller indices? All the parallel equidistant planes have the same Miller indices. This is the first point. All the parallel equidistant planes have the same Miller indices. First point. Second point, a parallel plane to one coordinate has an intercept of infinity. A parallel plane to one coordinate has an intercept of infinity. இப்போ ஒரு plane இருக்கு, ஒரு plane ஒரே x axis லியோ along the y direction லியோ இல்ல along the z direction லியோ நீ வரைஞ்சினா அந்த பிளேனுக்கு தகுந்த அளவு, ஒரு பிளேனுங்கிறது ஒரு பெரிய ஏரியா, அப்ப இன்ஃபினைட் நம்பர் ஆஃப் இன்டர்செப்ட்ஸ் ஒரே பிளேன்லயே கிடைக்கும். திஸ் இஸ் த இம்பார்ட்டன்ஸ். If the Miller indices have the same ratio, இப்போ ஒரு plane உடைய designation 622, another plane உடைய designation 311, என்ன மீனிங்னா the planes are parallel to each other. இங்க பாரு 622ல பாதி 311, that means இத மாதிரி ஒரு கிறிஸ்டலுக்கு ரெண்டு பிளேன்ஸ் இத மாதிரி கிடைக்குதுன்னா இந்த பிளேனுக்கு parallel இந்த பிளேன் இருக்கும். 622 பிளேனுக்கு parallel 311 பிளேன் ஆனது இருக்கும். So this is the third point. Another point, if HKL are the Miller indices, we know the Miller indices are represented by HKL. If HKL are the Miller indices of a plane, then the plane cuts the axis into HKL. உள்ள எக்ஸாம்பிள்ல நம்ம பார்த்திருக்கோம். அது A பொசிஷன்ல எத்தனை இன்டர்செப்ட் வருது, B ல எத்தனை இன்டர்செப்ட் வருது, C ல எத்தனை இன்டர்செப்ட்னு வருது, அதை பேஸ் பண்ணி தான் இந்த HKL. ஸோ அந்த HKL எப்படி இருக்கும்? in equal segment respectively. If HKL are the Miller indices of a plane, then the plane cuts the axis into HKL in equal segment respectively. Equal segment அது என்ன இருக்கும்? உடைக்கும், கட் பண்ணும். Therefore, these are the importance of Miller indices. All the parallel equidistant planes have the same Miller indices. If the plane is drawn parallel to one coordinate has an intercept of infinity, if the Miller indices have the same ratio such as 622 and 311, then these two planes are parallel. If HKL are the Miller indices of a plane, then the plane cuts the axis into HKL in equal segment respectively. So these are the importance of Miller indices. Now you see some examples of Miller indices of some cubic crystals. These crystals are cubic crystals, we already know. That is, in Breve lattice also we saw three-dimensional cubic lattice. Those are the three-dimensional cubic crystals. So in that cubic crystal, how we name it? You see in the first example. இங்க பாரு, இந்த x axisல எந்த கட்டுமே இல்லை, எந்த இன்டர்செப்ட்டுமே இல்லை. y axisலையும் எந்த இன்டர்செப்ட்டுமே கட் ஆகல. எங்க கட் ஆயிருக்கு? only z axis மட்டும் தான் கவர் பண்ணிருக்கு. Therefore, in x axis no intercept, in y axis there is no intercept, but only in z axis there is a intercept. அதனால the name of this Miller indices is plane of this, I mean the name of this plane is 0, 0, 1. Now you understand how we are naming the Miller indices. You see, now you see Z direction la no Miller indices. Inge Z Y direction la no intercepts. Only in X axis only it is fully covered. Okay. Therefore, the Miller indices is 1, 0, 0. Now you tell me this. Yes. In X axis there is no Miller indices. This bit na, you don't consider this bit. If it is fully covered, then the intercept. Otherwise, there is no intercept. Here you see, in Y axis there is the intercept. In Z axis there is no intercept. Therefore, this plane is 0, 1, 0. Now here you see X axis full, okay, but in Y axis there is no full reading intercept, but in Z axis you see there is the intercept. So this plane is called as 1, 0, 1 plane. Here you see in X axis there is plane, in Y axis there is a full plane, but in Z axis there is no plane intercept. You see here there is no intercept. Here X intercept is there, Y intercept is there, no Z intercept. Therefore it is 1, 1, 0. Here you see there is a Z intercept, there is the Y intercept. Therefore this is 0, 1, 1. 0, 1, 1. Now, what is this? Name it. Try it. How many intercepts are there? Yes. In X axis there is the intercept. Y axis there is the intercept. Z axis there is the intercept. Therefore, what is the value? Yes. In bracket, 1, 1 and 1 is the correct answer. You see this diagram now. X intercept is there, Y intercept is there, Z intercept is there, but no Y intercept. What is the plane? So then 1, 0, 1. This is also 1, 0, 1. This is also 1, 0, 1. You understand now? Okay. So these are some Miller indices of some cubic crystals. In this way, we can find out what is the designation or what is the name of that plane in terms of Miller indices. How to find out Miller indices? There will be 4 steps. Intercept கண்டுபிடிக்கணும், reciprocal கண்டுபிடிக்கணும், the reciprocals க்கு LCM கண்டுபிடிக்கணும், அதுக்கு அப்புறமா அதை என்ன செஞ்சிடணும், அந்த reciprocal அந்த LCM பெருக்கும் பொழுது நமக்கு என்ன கிடைக்கும், Miller indices கிடைக்கும். Okay, yeah, right. Then what are unit cells? Unit cell na enna? To describe the crystal structure is divided into small repeat entities called unit cells. ஏதோ ஒரு என்டைட்டி ஒரு குரூப் ஆஃப் பாயிண்ட்ஸ் திரும்ப அந்த கிறிஸ்டல் ஸ்ட்ரக்சர் ஃபுல்லா வரும். அந்த திரும்ப வர அந்த பாயிண்ட்ஸுக்கு பேரு யூனிட் செல்ஸ்னு பேரு. டு டிஸ்கிரைப் த கிறிஸ்டல் ஸ்ட்ரக்சர்ஸ், the crystal structure is divided into small repeat entities. அந்த crystal structure நம்ம சின்ன small entities நம்ம என்ன செய்யலாம், we should divide it. That small repeated entities are called as unit cells. In every crystal, some fundamental grouping of particles is repeated. அதில் எப்படி இருக்கும்னா some fundamental particles என்னாகும், again and again it should be repeated. Such fundamental grouping of particles is called a unit cell. These are the different definitions for a unit cell. Then unit cells are mostly parallelopiped or cubics. அதோட ஸ்ட்ரக்சர் எப்படி இருக்கும், ஒன்று parallelopiped இருக்கும், அப்படி இல்லைன்னா எப்படி இருக்கும், cubic ஸ்ட்ரக்சர்ல இருக்கும். அப்ப அதில் என்ன இருக்கும், 3 sets of parallel faces இருக்கும். கியூபுக்கு we know there are 3 faces and அந்த மாதிரி 3 sets 6 faces. So 3 sets 3 into 2 3 sets of parallel faces இருக்கும் யூனிட் செல்லுக்கு. Thus the unit cell is the basis structural unit. Basis இல்ல, basic structural unit or building block of the crystal structure which has the crystal geometry and atomic positions. By understanding the unit cells, we should find out the crystal geometry and atomic positions of the crystal. So unit cell is nothing but repeated entities. That repeated entities may be some fundamental grouping of particles. These unit cells are parallelopiped or cubes in nature. Therefore, it has 3 sets of parallel faces. Therefore, these are the basic structural unit or building block of the crystal structure which has the crystal geometry and atomic positions. Then what is lattice parameters? The unit cells are represented by 3 vectors A, B, C. That is x direction, y direction, z direction we are telling now. So that A, B, C. Otherwise it will be represented as A, B, C. It is the vector. Then the intersecting angles alpha, beta and gamma. The origin with A, the origin with B, the origin with C. That angles between the origin A, between the origin and A, it is alpha angle. B and the origin, it is a beta angle. C and the origin, it is the gamma angle. Therefore, what is the lattice parameters? Combination of these A, B, C and alpha, beta, gamma are called as lattice parameters, which are nothing but the representation for a unit cell. So a unit cells are represented by 3 vectors A, B, C and the intersecting angles alpha, beta, gamma called as lattice parameters. Okay, you understand now? Okay. So in this class, what we saw, what are Miller indices and what should be the definition for Miller indices. Then how to assign Miller indices, that is how to find out or how to designate or how to name the crystal planes. Then I have given one example for you. Then we read about importance of Miller indices. Then Miller indices for different structures. Then we read about unit cells and lattice parameters. So if you have any doubts, please post your doubts with that WhatsApp in 3rd year WhatsApp group, so that if a student having a doubt and if he is asking the doubt in that group, then it will be seen by others, and also I will give the reply in the next video, so that all the students will make benefit of it. Okay, so be safe with good health. Meet you in the next class with the next lecture or the next topic. Okay, have a nice day. Thank you.